Okay, so let's talk about effusion and diffusion. Now, the main difference is that during effusion, right, you have gases in a container, and if you were to poke a little hole through it, right, the gases would kind of disperse out, right? They would just leave the container. So effusion is gases leaving through a container, sorry, gases leaving a container through a tiny hole. Now, diffusion is when you have a container, let's say all the gases are like clumped up in one area, right? And diffusion is when they kind of just disperse randomly. So they kind of spread out. Now, that's pretty much the only difference. Now, for calculation wise, well, it's an inverse square root. So that means that the rate equals 1 over the square root of molar mass of the gas. So what does that mean? That means that the lighter you are, the less mass you have, the quicker you can defuse or effuse. Now, there's something else to keep in mind, that during the test or quiz or whatever you have, right, you will be given an equation or rather a problem. Oh my god, hold on. Now, something else to keep in mind, that you might be given a problem on your quiz or tests or whatever that asks to do some calculations. No. Oh my god. Now if you're trying to compare gases, like the effusion rate or the rate of gases, right? That would be rate of gas 1 divided by rate of gas 2 equals the square root of the molar mass of gas 2 divided by the molar mass of gas 1. So remember that. Now, during an exam or a test or quiz or whatever, you'll be given a problem, right? So let's say you have oxygen gas, right? And let's say the rate. So during an exam, you'll probably get some questions that ask you to find the molar mass, or rather like what gas it is, right? Now during an exam, you'll probably get some type of questions like this, right, which gives you a ratio of rates and it asks you to find what gas it is. So for example, let's say you have one of the gases is O2 and the ratio of the rates are 1.12 is the ratio. And it asks you to find what the other gas is. So what you have to do is pretty simple. You know that rate 1 over rate 2, so the ratio equals square root of molar mass over molar mass 1, right? Now, on an exam or a test or a quiz or whatever, you might be given some kind of a problem like this, right? Where it tells you that the ratio of the rate of the gas is 1.12. and one of the gases is oxygen, and it asks you to find the other gas. So we know that the ratio equals the inverse molar mass square root. So what that means is that 1.12 equals the molar mass of the second gas divided by the molar mass of the first gas and square root of that. So molar mass of O2 is 32 grams per mole. So that's MM1. So it's 1.12 equals square root of molar mass of the second gas divided by 32. Now, how do you solve for molar mass of 2? Well, you square both sides, and then you get 1.25 equals molar mass over 32. And how do you solve for that? You multiply by 32, and we get 40.1. And if you look at your periodic table, whichever gas has molar mass of 40.1, and that equals argon. So the second gas is argon. So just remember that equation. Now let's talk about speed and kinetic energy. Speed of a gas and the average kinetic energy, rather. Now, what's the main difference? Well, the speed is associated with the temperature and the mass. Kinetic energy is only associated with temperature. Now, what that means is that at any given temperature, all gases, no matter the size, the mass, or whatever, they all have the same kinetic energy. And the equation for that is 3 halves RT equals KE. So, yeah, it all depends on temperature. Now, gotta be careful here because R is in 0.0206. R, in this case, you have to use 3.18, 3.184, and the units for that are joules per Kelvin mole. So that's kinetic energy. It's pretty simple. And speed. Now, speed, we said it depends on temperature and mass. So what that means is that if you have multiple gases all at the same temperature, whichever one has the lowest mass is the quickest, has the most speed. Now, if you're given, let's say, multiple gases and they all have different temperatures and different masses, then how do you determine which one has the highest speed? Well, lucky for you, there's an equation. It says your average speed equals square root of 3RT divided by m. Now, careful here because R is once again 3.184. You have to use 3.184 joules per Kelvin mole. And m, you also got to be careful here again. M isn't just your mass in grams, it's your kilograms per mole. So you can't just use grams per mole, you have to use kilograms per mole. So yeah, so just keep in mind that average kinetic energy is associated with temperature. All gases, no matter what, how heavy or how light, how big or small they are, at the same temperature, they all have the same kinetic energy. And speed is associated with temperature and mass. So if we want to find the average speed of oxygen at, let's say, 0 degrees Celsius, right? We know that the mass is 32 over 1000, right, which equals 0.032, and our temperature has to be in Kelvin, so it goes 273 Kelvin. Now all you do is just plug and chug. 3 times 3.184 times 273 all over 0.032. You do the math, put in the calculator. Right, and you get 285. It's usually meters per second. So that's the speed of oxygen at 0 degrees Celsius. And yeah.